Hi, my name is Shar Jamil, and today I'll be answering the question of what advice would you give somebody hoping to enter the data science field professionally, along with what model building tools would you recommend, which online courses or other resources would you recommend? So I started off this process by going over 7 or 8 different job postings online for data scientist one level positions. They were across the board from private companies like Amazon to the public sector, places like City of Denver. And expectations varied across companies and positions, but for the most part, this was the crux of what I saw. So the data scientists are expected to work with others, other stakeholders in the company, such as architects, database groups, software development groups, subject matter experts in the business, to really understand what the business problem is that they're trying to answer, where the data can come from. Once the data is extracted, you're expected to cleanse it and refine it to match it to different algorithms and models. This is where the actual development part comes in. So you'll be building models using different machine learning techniques and setting the right machine learning model to that specific problem and data set. So these algorithms are supposed to deliver value and in the end give that business an edge over the competition. As you're collecting data and refining it, you might have to talk to other members of the organization who are not as technically savvy. So converting those analytical concepts to English, knowing exactly what you're asking for and how that translates to the business speak is a good talent to have. Lastly, once that model is working fine and you're getting some insights out of it, you'll have to present the findings to the business. And I'll go over that a little bit later in the slides. But you'll know how to present and communicate these results, and then harden the models for production deployment. Production isn't exactly like your dev or testing levels if you're familiar with software development. So the production code will have to be scalable. It'll have to be error-free and secure, and then it'll have to adapt as the data changes or the business rules change. You might have to watch the performance over time, and you might possibly decide to optimize it for better processing speed, things like that. So working backwards from those expectations in a role, these are some of the ways that I've found of how to meet them. Almost all of the job postings required a degree in math, science, or engineering. If you didn't have that, it seemed like it would be really hard. You would definitely want to study up on statistics, probabilities, linear algebra, and multivariate calculus. You'll have to have extensive programming experience with either Python or R. And so that's understanding data structures in Python, understanding algorithms. So you'll want to spend time pursuing programming problems, which could be as simple as printing out the Fibonacci series or as hard as predicting the election results based on tweets on Twitter. You'll also want to brush up on queries in SQL, joins, optimizing queries, understanding how you can extract data from a database and transform it to make it be what you need it to look like. You can obviously do that in Python as well, but some things are just better done through queries because it's a little more optimized. You're on the data layer as opposed to pulling the data and then working on the machine layer. You will want to spend some time learning Linux. A lot of companies will have their development environments in Windows or Macs, but then have servers where the actual code is deployed. So you'll want to be able to know how to use tools like PuTTY to tunnel into Linux boxes, to create file structures, delete files, edit files, tarring, untarring, which is Linux's way of zipping or unzipping a file. A lot of companies outsource their infrastructure to places like AWS or DigitalOcean, Heroku. So knowing Linux and how kind of that infrastructure works is important. You'll want to know DevOps concepts. That's a fairly new and ever-changing domain, but understanding that we use tools like Jenkins as an example to automatically build the code once it's checked into version control, and then run automated tests, and then Jenkins will actually move that code for you or run the scripts that move the code from your development box to production. Versioning is a good concept to know as well. Tools like Git, the same people that run GitHub manage Git, is a good tool to know. Versioning is a concept where as you're working on a team or even individually, I use Git for all my personal projects, but as you code, you'll incrementally check in those features that are coded into the version control software. So you have some kind of history of what you worked on, and you can roll back if things go south or your machine goes down. Usually your Git repository will be hosted on a different machine, so you don't lose everything when you lose your machine. It also is really great at handling when different people work on the same files, handling conflicts and things like that. Lastly, you'll want to attend meetup groups. Meetup.com is a great site that hosts all manner of interest-based meetups. So you'll want to check out what's going on in your area. I know in my area we have interesting talks every week on not just data science, but all sorts of software development related presentations. You'll get to know the data scientists in your community, all the companies. Some of the companies might send representatives to those meetings, so it's a great networking avenue. Along with that, you also want to spend time reading data science blogs online or following influential data scientists. This field changes on a weekly basis. It seems like there are breakthroughs made, so you'll want to stay abreast of what's going on in the industry. So it looks like I covered some of that, some of the information from this slide and the previous one, but yeah, you'll want to follow emerging trends in data science. You'll have to stay up on what tools are being used in the industry and secondary and third level data sources in the industry. I'll cover some of this in the coming slides, but data governance is a big part of data science today with what's going on with Facebook and Europe and GDPR and all that. Our company, the company I work for, has a lot of business in Europe, and we're definitely affected by understanding who controls the data, what you can do and not do with customer data, things like that. You'll want to know. It's definitely very important. And those rules often seem like are evolving. Lastly, you'll want to know some or have a good command on soft skills. So your role in the company is to serve as a liaison between the data and the actual business component of the company. So your success is measured by how well you can tell a story based on your findings and make an impact. That's really where your challenge will be. So if you can make a convincing presentation the audience cares about and your findings are actionable, that's great. You also don't want to spend a lot of time over engineering without coming up with actionable items that the business can follow, because you're not providing value at that point. You also want to understand things like business cycles. What happens in the business is way more important, and what the customer is dealing with is way more important than little idiosyncrasies in development. So you can spend your whole life optimizing an algorithm, but if it doesn't achieve anything for the business, then it doesn't really matter that much. An example of this is understanding, like in our business, no code gets deployed to production between November and February, because that's when we have a lot of load on our sites. So between November and February is a great time for a data scientist to just kind of go into their bunker, come up with an algorithm, understand data, optimize their algorithm, and then come out in March when the business cycle is kind of ramping down and people have time on their plates to actually listen to you and understand your findings, and your code can find its way into production. Next, I'll cover some model building tools. Obviously, we're familiar with pandas through our class. So it's a great tool for looking at subsets of data, manipulating it, and analyzing it. You could use it to kind of identify some bad columns and remove them before we process the data. Matplotlib was great for visualizing the data and seeing where some of the sweet spots might be or outliers might be. Then Scikit, Keras, and TensorFlow were all machine learning libraries. It seemed like Scikit was, TensorFlow was really popular, but it also requires a lot of configuration, babysitting, whereas Keras is a little more user-friendly. Things are moving towards the Keras direction, but all three of these are highly touted, and I would definitely look into all of them, but then pick one and kind of run with it. I also wanted to cover machine learning as a service. It definitely seems like the future, or at least it could be a part of our data science future. It's very far off right now and sort of rudimentary, but I think over time it'll improve the efficiency of machine learning scientists and data engineers by automating some of the more tedious aspects of the job and enable you of conceiving higher level challenges. But it is garbage in, garbage out. So Google AutoML is kind of using AI to do AI. So if your data is not refined and near perfect, then you won't get anything out of it. So ultimately, this isn't replacing data engineers, it'll just kind of help them work better and more efficiently. To answer the last question of which online resources I would recommend, firstly, I would recommend Andrew Ng's Stanford machine learning course. That seems to be the bedrock of all courses on data science. It seems like if anybody's starting out there, right away recommended to go check out Andrew Ng's machine learning course. That's on Coursera, so it's available for free. Next, I would recommend some Kaggle competitions, especially to brush up on your Python and R skills. I wouldn't do any of the top paid or prize competitions, but instead follow some of the tutorials, try to do some of the ones that they have online implementations of, so you can kind of compare what you did with others and see how you stack up and possibly learn more. I have to be a homer, so I have to recommend Harvard's CS 109 data science course. The version from 2015 is available online with all the exams and quizzes, homeworks, and everything. So you can check that out. I'm a big fan of the Amazon's AWS guides or learning paths, and they had one for machine learning, the data science path that I checked out. That seemed pretty cool, and also it uses a lot of the AWS infrastructure. So if you want to be familiar with both at the same time, that's a great way to go. If you decide you don't want to do anything with Amazon, then Google's machine learning crash course also provides the same kind of thing, but just on Google's infrastructure. And then also want to recommend this book, Hands-on Machine Learning, that focuses on coding with Scikit and TensorFlow and how you would use those tools to apply an algorithm to your data. Um, there are a few other things you could look into, like survival analysis, hypothesis testing, modeling, time series modeling, decision trees, clustering. These are all important terms in data science, and you'd be best served if you check those out and spend some time understanding them. That's kind of all I have. If you, oh yeah. So I also wanted to mention, lastly, uh, as the industry changes a lot, this site is a great resource for looking up data science papers and understanding kind of what is happening at the cutting edge of data science. And I also wanted to mention it's always great to have an online resume. And GitHub is a great place because you can actually upload all your kind of practice exercises or implementations on GitHub that you can then share with somebody. Say you run into a recruiter or a data scientist at a meetup, then GitHub is a great resource to kind of just walk them through your code while you're there. Thank you very much. That's all I have. If you have any questions, feel free to reach me through Yellowdig.